Solving trig equations using advanced identities. Now this problem is definitely in the watch out category. Just because there are identities that can be used in an equation doesn't necessarily mean that that's the best way to go. For example, in this problem, you might be looking at this sine 2x thinking, oh, there's an identity for that. We should get rid of that and replace sine 2x with the identity. Well, that is not the best way to go in this problem at all. Take a look at the equation as a whole. And what you're supposed to notice is that in both cases, the angle that's attached to these trig functions is the same. It's 2x. Well, that means I don't need an identity to get rid of the 2x. I can just use plain old u substitution. In fact, this will be a very easy substitution. As soon as I replace all of the 2x's with a u, I end up with a very simple looking equation. Sine squared u plus 4 sine u equals 0. In order to accomplish our step A, I can factor that left side. In fact, there is a GCF of sine u. I can pull that out to the front. I do have a 0 on the right-hand side, and so now I can use the fact that when I multiply two items together and get 0, one of them has to be 0. So either sine u equals 0 or sine u plus 4 equals 0. And I end up here with two simpler equations after I subtract that 4 to the other side. Sine u equals 0 and sine u equals negative 4. That was step A. Trig function, single letter, equal sign, and number. I did not need to use an identity because I could just use the u substitution. So now we solve each of these. Do you see that one of them has no solution? You can't have a sine ratio of negative 4, so I'm able to throw that one out. The only little equation here I need to solve is sine u equals 0. I can't draw reference triangles for 0, so I'll have to go to the unit circle. Let's see, find the solutions within one period. So where would I have a b coordinate of 0? Wouldn't it happen here at the point 1, 0, and then here at the point negative 1, 0? So it looks like within one period, we get the solutions 0 radians as well as pi radians. Remember, u was something that we made up. It wasn't in the problem. We do eventually have to go back to x, but we can't do that with u substitution until we finish step C, until we write down all of the solutions. So essentially this was step B. Step C, for u, do I need two lines here? I don't think I do. These answers are evenly spaced out. So if you just start at 0 and go every pi, you'll hit another answer, 0, pi, 2 pi, 3 pi, 4 pi, etc. So u would just be that first answer plus multiples of pi, the distance between all the answers, which really is just k pi. Now that we have finished step C, at least in terms of u, we can go back to the substitution and we can return to x. If u is equal to 2 pi, that means 2x is equal to k pi, and of course I can divide both sides by 2, and I end up with x being any multiple of pi over 2. I could leave the answer like this as well. That would be fine. I think I just like this one because it reminds me of what it means. We're basically saying any multiple of pi over 2 is a solution to the original equation. So be careful. Identities are very useful in solving some of these more complicated equations. Just think before you act. If all of the angles, though, are the same, a simple u substitution is definitely the way to go. Thanks for watching.